Hello, everyone. I'm Hongyu from StorSwift, and together come here with my team. And I'm very all of here on behalf of my team to introduce StorSwift scaling architecture. In the next page, I will introduce the subtopics about scaling as a service and the scheduling and the storage. First, let me introduce my team. Okay, we are still focusing on building infrastructure and the core modules development. And we have ever built traditional enterprise storage solution for customer. And now we transfer into decentralized storage field and also has our team also has the experience on T and ability on zero knowledge proof for privacy computing. We are also interested in the data analysis, and we developed the blockchain browser and wallet plugin for browser and the mobile version wallet. We also developed the Rust implementation. That's the distributed randomness. Moreover, we also provide a consulting service for customer and provide the project-related algorithm optimization solutions based on CPU, GPU, FPGA, etc. We work in close cooperation with the facility suppliers such as Intel, AMD, Alibaba. For the new product performance verifying, we have participated in the zero competition and got 2 positions, winning 2 fourth results. J-Prize is an annual competition focused on the promoting the use and the development of the zero knowledge cryptography. Okay, let's step into the scaling as a service, which aims to enhance the ability of data on board to the network. Here is the overview of the scaling as a service. The left demonstrates the service architecture according to the business model. We group the business model with a winning, selling, and a window. Yeah, and we have different core modules for the service workflow. And the right side is coming from the magic grid work. I think so many people have seen this diagram in GitHub and discuss more about this. We also follow on that for the detailed implementation. Yeah, here is a core modules breakdown. The left side is a storage provider side, which composed with Lotus Mine for the ticket and their deal info, and the Lotus for the follow the RPC request and the post the work for winning and the window and the data cable for the deal info import. And the right side is a core service. We separated the selling modules into Lotus Walk from the official release and the StorSwift Walk with optimize and super national walk, because they have the different target for the selling, especially for the PC1. And the bottom of the right side is the core modules for the schedule and the task manager and the C2 cloud service and the storage components. So, okay, here is the workflow in the selling as a service. Basic is a very long basic logic. So select the selling as a service provider. We do with the offline agreement prepare their information and data and start a remote selling service. Of course, we can monitor the selling data by the web UI. And then the SP side can get the sales sector data via online or offline post office such as that. Yeah, of course. Come here, I would like to introduce more about the difference between the StorSwift walk and the supranational walk. That's the different purpose for especially for the PC1, the phase. For StorSwift walk, we maximize the memory usage. The detail I will introduce in next page. The supranational walk is very special for the PC1 with the NVMe protocol disk usage. Because for the NVMe disk usage, it will use the maximize the PCIe with the new hardware configuration. That's the difference. And the SS walk maximize the memory usage based on current the hardware configuration of SP side. For PC2, yeah, the SS walk with the multi-GPU working on the group columns. For example, if you have 2 GPU cards, and then one GPU will working on the first group from 0 to 4, and another GPU will work on the 8 to 7. Sorry, one is 0 to 3, and another will work on 4 to 7. For supranational walk, it will work on with the multi-GPU working on the same column one by one. They are both on one task. Yeah, for C1, it's the same. For C2, because during the C2 phase, they need so much memory to loading the parameters. So basically, the server side, we are running server tasks in parallel. So if they need loading the parameter data, the data is 45 gigabytes. So it will multiply the memory usage. So we use the shared memory to cache the parameters during the multiple processes. So it will reduce the parameter loading cost. So we also do some algorithm operation optimized. For superlinear side, they have refactored the group 16. So we also integrated the grid job into the scaling architecture, scaling architecture. Okay, here is a detail about the PC1 optimization. Last year, we also introduced this idea with the Lotus team in Lisbon, in the Lotus internal meeting. We rank the tasks because for the detail of the PC1, one task for 32 sector selling, it will consume 64 gigabytes of memory at least, except the parent cache. Yeah. So we can reuse the pre-allocated memory during the tasks that not reached, that not touched. And then we can rank the task in a queue, and then once the task finished, the untouched memory will be reused. That's the difference. That's the idea. We maximize the memory usage. It will increase the production efficiency up to 25% at least, and without any side effect. So I put the link at the bottom of this page, and we also share the experience with some community members last year in Lisbon. Okay, here is about the scheduling. To scale the ability of selling, the key point is at schedule, which makes it possible to high efficiency production. Here is a typical performance bottleneck benchmark. And of course, some data is old during the page slides right. Yeah, the right side is a basic workflow of the selling process, and the right is a typical performance data with the related hardware. Of course, once we replace with a new optimized solution, this data will be more better. And also, it's a typical resource consumption about the selling process with different sector. For example, 32 sector, during the PC1, it will produce the 355 gigabyte and treated with 64 gigabyte. And the total disk consumption will reach 455 and 52 gigabyte. And then the similar case for the 64 gigabyte will huge disk consumption. And the C2 is at least 450 gigabyte RAM consumption and some swap to assist on that. And the right side is we combine the resource consumption and group the tasks in different read domain. The other piece and PC1, PC2, C1 to group one server, and the storage is a distributed storage solution. And the right is about the C2. We group the C2 task into the cloud service. Yeah, to make the high efficiency production happen, we need calculate the time consumed during the selling process. And then we need very clear about the key constraints of the PC, during the PC1, PC2, and how much the task will to configure. Yeah, here is a workflow for the scheduler to invoke the tasks. 1, 2, 3, 4, 5 steps to make the scheduler work good. Yeah, here is a Zk Cloud for C2, because after the C1 finished, they produced 26 megabyte data as an input for the C2. And if you compress the data, it will be less to 7 megabyte data, and it's very useful, easy to work with the cloud service and make it happen for the hardware provider to join the selling service as a player rule. The workflow is more complicated, but it's with the ticket system support, it's a very a mature solution for the C2 task selling service. Yeah. The last is about how to make the scanning ability for the storage solution. We have the storage manager integrated in the scheduler to scheduling the storage tasks workflow, because it's very important for the tasks in parallelized. For example, if you have the selling task and the window task and the winning task, some tasks has a high priority of the I/O bottleneck. So we need to involve the distributed storage solution to block the issue happen. So the right side is the status we checked in the production environment. Okay, thanks for listening.
Thank you so much. Do we have any questions? Shanuj?
Can you go back to maybe the slide where you talk about your scheduling? All right, yeah, this one. I know StorSwift uses sort of like a custom version of Lotus.
Yes.
How much of the current scheduler do you use? How do you see the changes that we presented earlier on to alter what you do with that?
Currently, we make the change with the Lotus Mine side. I think it's totally totally it's different with the official site. So because it integrates with a more complicated scheduling according to the task. So, yeah.
Basically, it's a completely different mechanism there you're using to currently.
Yeah. Well, in the schedule side, other side is the same. Other side is the same because we are try our best to keep the most part of the function to same with the official release. Then we can easier to integrate or upgrade the version. Okay.
I have another question around the ceiling as a service.
Yes.
So currently, there does not seem to be a standard for how ceiling as a service functions across like implementations, and I think there's a big gap there because like you can create be a ceiling as a service provider, but then like it should function across both implementations and custom code in the network so that everybody can like benefit from either being a ceiling as a service provider and then being able to seal sectors for everyone in the network. So I think there's probably a possibility for us to like use the FRC standard, like Filecoin request for comments, and we could like create standards among us so we can like define those APIs.
Yeah. So we hope we can follow up the one API to the API set to follow to define the standard of the selling service, and then make the developers or community members to work on the same page, right?
Yeah.
Then to reduce the cost during the
That would be really good.
ecosystem.
So there will be a workshop on this on ceiling as a service later today. So maybe we should tackle that problem.
Right, yeah. Thank you.
Thank you so much.